This is section 3.4, and we're now going to take what we learned about quadratic equations and their graphs to talk a bit more about maybe using the graphs to actually solve the quadratic equation in the first place. We know that if we have a graph of a quadratic function, it's going to look like a parabola. And we further know that on that parabola, the zeros can be located very easily by just looking at the x-intercepts, right? The x values at the x-intercepts are the zeros. Those are the solutions for when the function is equal to 0. So we can turn that around and we can say, well, if we have an equation and we make sure that one side is 0, we can do that algebraically, so we get this form f of x equals 0. If I then graph f of x using technology now, I can just use those x-intercepts from the graph to figure out the zeros of the original function. So we're going to solve each quadratic equation by graphing with technology, and then we'll just kind of put a little rough sketch to kind of show how we got our information. So as I look at my first quadratic equation, I want to make sure I start with this equal to 0. My x-intercepts aren't helpful to me unless they correspond to the zeros, right? So I have to have this equal to 0. I will add x squared and subtract 9. So I get 0 equals 2x squared minus 5x minus 7. I'm now going to go ahead and graph that function, because where that function has its zeros, or its x-intercepts, will be the solutions that I'm looking for. So I'm going to graph y equals 2x squared minus 5x minus 7. And if I want to see the whole parabola, I can adjust my axis just a little bit. There it is. And I can see that the zeros of that function, based on the x-intercepts, would be at -1 and 3.5. So 0, 0, x equals -1, and x equals 3.5, and that would be the solutions to that equation. In terms of just sketching a little graph here, all I really want you to show me is this, that you graphed your function, and when you did, the x-intercepts were -1, 0, and 3.50, which then corresponded to the zeros or solutions to the equation that you found. You don't have to be more accurate with your sketch than that. I just need to see the part that's relevant to locating the zeros. So solving equations graphically is fairly straightforward, right? We make sure it's equal to 0, look for the x-intercepts, and the x-intercepts then give us the zeros of the function. Let's try a couple more. Our next one is already equal to 0, so I don't need to do anything to that one. I'm just going to go ahead and graph it. 3x squared plus 2x minus 4. There are my x-intercepts, and you'll notice that this time those are almost certainly rounded off decimals, right? They're probably not exact values. That's one thing that I do sacrifice when I use a graphical method to solve an equation. I'm never going to get the exact value, like 3 plus the square root of 5 or whatever. I'm always going to have to be okay with the rounded off decimals, but oftentimes that's sufficient. So in this case, I'm going to have to say that my zeros are x is approximately -1.535 and x is approximately 0.869. And you'll notice I used the little wavy equal sign to indicate that I understood that those were rounded off decimals. and not exact values. But it makes for a really fast and efficient way to solve an equation. And again, I'm just looking for a quick little sketch here to show me that you understood the relationship between the graph and its x-intercepts and the solutions to your equation. All right, we'll try a couple more. In C, this one's not yet equal to 0, so let me get it equal to 0. I'm going to subtract the x and add the 5, so that now I truly just need the zeros of the function. And you'll notice that this parabola does not have any x-intercept. So I'm going to sketch this right now on my paper, and then we're going to talk about what that tells us. It never crosses the x-axis. So my sketch just shows that parabola that stayed always above the x-axis. There are no x-intercepts. So what does that tell me about my original equation? Does it have no solutions? Well, you all know how to find solutions to this by hand, right? For example, we know we could use a quadratic formula on anything. So this definitely has solutions, and I could find them with the quadratic formula if I wanted to. Why would the solutions not show up on the graph? Well, if you remember last time when we were graphing parabolas, if the zeros were imaginary numbers, we don't see them on the graph, right? So the best I can do with technology here is to say there are no real valued solutions. I know that there would be imaginary solutions because this has to have solutions. All quadratic equations do. So there must be imaginary solutions. But they cannot be found on by a graph. So we're starting to see that, yes, this is a great method, but there are some limitations to it, right? What we saw here was one limitation is we can get rounded off decimals, but if we wanted exact values, like, 5 plus the square root of 3 or something, we're not going to get that from a graph. And if the solutions happen to be imaginary numbers, we're not going to get that from a graph. So powerful method, but with some limitations. We'll discuss that a little bit more in just a minute, but let's go ahead and look at D first. Again, this is not yet equal to 0, so I'm going to go ahead and get it equal to 0. And for right now, I'm just going to copy the left side the way it is, and then I'm going to have to add the 16 to get that to equal 0. If you wanted to, you certainly could distribute the 3x. It won't hurt anything. But I just want to point out, you don't have to. Desmos is going to graph that just as well in the form that it is now as it would if you multiplied it out. So why not? Let's not work any harder than we have to, right? I'm going to type it in just like that. All right, and it looks like this one happens to be one of those that just has one x-intercept, right? The x-intercept's right at the vertex. That's the time when there's just one. X is approximately 1.333. I'm pretty suspicious that that's 1 1/3. Sometimes you'll recognize the decimal patterns, and that's fine, but since we're solving graphically, I'm just going to write it as 1.333. And I'm making a quick little sketch of what I see here. The x-intercept at 1.333, comma 0. So the graph looked like that, and that is my x value. In a case like this, and again, we'll talk more about this as time goes on, but we saw in the last section that when there's only one 0, just one x-intercept, we say it has multiplicity 2. It actually occurred twice in the solving process, right? We don't have the solving process written out this time, but we know that must be the case based on what we've done in the past. But that is my only actual 0, my only actual solution to that equation. So, discuss graphing technology method of solving equations. What are advantages and disadvantages? Well, of course, the big advantage is fast. And you don't have to worry about, operator error, right? You don't really have to worry as much about, making a little arithmetic error, or a little algebra error. So it certainly reduces error. About the only thing you could possibly do was accidentally type in the function wrong. But it's quick. It's pretty accurate. There are a couple of disadvantages. We won't get exact values unless they happen to be nice whole numbers or perfect decimals, but we don't always get exact values. We have to be okay with rounded decimals. And we aren't going to find imaginary solutions this way. So if we are going to use a graphical method of solving, we need to be sure that those two things aren't important to us. And if they aren't, they're not always, then a fast, relatively low error method is a great one to have. Okay. Before I leave this section, I'll just mention, I won't list it as an advantage yet, but eventually we're going to see, is this method really specific to quadratic equations? Does it matter that this is quadratic, has an x squared? Not really, right? You could use Desmos to graph any equation or any function. This could be an x cubed or an x to the 4th, or it could have a square root in it or something like that. Any equation can be solved graphically using this method, which is actually a huge advantage. Instead of learning, 15 different ways, one method solving any equation. But the disadvantages, the limitations, will be the same for all of them. They won't always give us exact values, and we won't ever find imaginary solutions. So we're still going to look at the algebra, but we're going to keep this as a great method as well. So, nice quick little section after a couple really long ones. That brings us to the end of 3.4.